All right, so here's what we're getting done today. Over in chapter 4 of the book we've been working through slowly and not entirely methodically. Chapter 4 is on 8-bit ports, right? We do the single write-outs to the ports one at a time, right? And we're sending out info out of one pin or reading it. We can shoot data in parallel out of 8 different pins at the same time. I think there's 4 different ports of 8 pins on there. Right here, we've got the Atmega outline, and you can see port A, port B on the left there, port C on the right, and port D. We're going to be using port C for this project. And in this chapter, it's kind of fun what we're doing. It's called the Larson Memorial Scanner. Surely you've either seen Knight Rider, the old TV show, or Battlestar Galactica, the old TV show. But no matter which way you roll it, there's an eye that's going back and forth like this. A set of LEDs, right? Or whatever they used back then. We're going to use LEDs. So we're going to set up this little guy right here to do exactly that, to do what Larson had those things to do. He was a producer on both those shows. And apparently I guess he's the one that made it up, even if they named it after him, but who knows. So we're just going to take this little gadget right here. It's the only thing I have on my board right now, because we're out of board space. So I just can't get in there. There, you see that guy right there? That's all we have wired up so far. So we're going to wire him up from here over to the pins right in this area, which are where that port C is on the old Cestino. Wiring the Cestino up for the Larson Scanner was a simple proposition that only took about 15 minutes. It's all pretty straightforward. Once wired up, I loaded up the sketch included with the book's download pack, and we were off to the races. I poked at the code a touch just to speed it up a little. The delay time sets how many milliseconds each LED lights up for. 80 seemed like the right spot to me. The bool is just a flag, so the program can hold a value of whether our LEDs are currently moving left or right. DDRC is set to all ones, which is saying, use all these pins for output. Port C is set with its rightmost bit set to 1, which will light up the corresponding LED. One of the big takeaways here is that writing a binary value to the whole port, we are controlling the state of all the port's pins in one fell swoop. We do a quick sanity check on line 40 to make sure our flag and our port are in alignment. Then at line 46, in our main loop, the magic happens. We first check at line 49 if we are at one of the 2 outer edges of LEDs. If we are, we flip our flag so we start heading the other direction. In line 51, we have a quick delay of whatever we set delay time to in the beginning of the sketch. This just provides the timing of the scanner. The smaller the number, the faster the scanner goes. In lines 56 to 61 lie the heart of the sketch. We just see which way we are going with the if statement, and then either shift our bits left or right. This causes that one lit up bit to be pushed up and down the port, and in this case, the lit up bit drives our LED eyeball. That's really all there is to this project. Pretty neat, huh? There's one more project in here called Binary Numbers on Display, and it is a simple few lines of code that just basically turn this into a simple second clock that's counting up in binary, which is really interesting in its own right. Just sitting there watching that, what it looks like is nifty if you know what's going on. If you don't know any binary, just look up the binary number system and you'll understand what this thing's doing in a moment. So the one thing I was curious about, we're simply setting the ports to all of them, or all the pins from that port, and then we're setting it to 0, and then we're looping. We're going to add one every time, and it's just basically going to count up to 255 and then start over.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32.
Yeah, binary. Binary is good to know about. Anyway, I hope you found that interesting and fun. And that's about it for today. We got the Larson Scanner going, and next time we're going to hopefully have some of those parts in to start talking MIDI to our little silly synthesizer. What do we call it? The pin buzzer. That's not a bad name, right? Well, we want to get some input to the pin buzzer synth. So that's where we're headed next. See you soon.